So this is 6n. Again, this is the terms here are more than or equal to 0. So it is not non-positive series. Okay, let's just do it directly. If you apply limit test, you have no conclusion. Let's see how first we skip this. For comparison tests and limit comparison tests, I don't know what to compare. Okay, so let's just skip this first. Ratio tests, if you try, I don't think you will have conclusion. For this also, okay, and you cannot use Leibniz test, so maybe you need to use integral test. So let's just use integral test. So we let fx to be e to the power of minus square root x for x is more than or equal to 1. Clearly this is continuous function. And okay, and for all, and we have and for any c, positive, x plus c is always more than x. This implies square root of x plus c is more than square root of x. Then minus square root of x plus c is less than minus square root of x. This implies e to the power of minus square root x plus c is less than e to the power of minus square root x. And this shows that f is a decreasing function. Okay. We also have the limit n tends to infinity of e to the power of minus square n is equal to 0. This is very clear. So we can apply integral test. So we have limit t tends to infinity integral from 1 to infinity, to t, e to the power of minus square root x dx. This, okay, how to solve this? We can let u to be this, then du will be 1 over 2 square x. Square x is just u dx. So dx is 2u du. So we have is equal to limit t tends to infinity integral of 2u e to the power of minus u du 1 square t. And for this, I can take out the 2. Okay, so I have 2 times limit t tends to infinity, the integral from 1 to square root t of u e to the power of minus u du. And we do integration by parts. Okay. This is my u, this is my dv. So this is equal to 2 times limit t tends to infinity of u times minus e to the power of minus u, u from 1 to square root t, minus integral minus e to the power of minus u du. And this is equal to 2 times limit t tends to infinity of, okay, minus square root t, e to the power of minus square root t, then minus when this is equal to 1, right? So minus minus 1, e to the power of minus 1. Then this will become minus e to the power of minus u square t 1. So we will have 2 times limit t tends to infinity minus square root t e to the power of minus square root t plus e to the power of minus 1 minus e to the power of minus square root t plus e to the power of minus 1, right? Yeah, correct. So we will have 2 times limit t tends to infinity minus square root t e to the power of minus square root t plus minus e to the power of minus square root t plus 2 e to the power of minus 1. This will tend to 0. This is just a constant. So our job is to think about this, whether this tends to a certain value or the limit of this doesn't exist. Okay, so we have, so here limit t tends to infinity of square root t over e to the power of square root t. I let u to be square root t, so I have limit u tends to infinity of u over e to the power of u. So this is equal to, by Hospital rule, 1 over e to the power of u, and this is equal to 0. So this also tends to 0. So this whole thing is just simply for e to the power of minus 1, and this means this integral here converges. So by integral test, the sum n starts from 1 to infinity of e to the power of minus square root n converges.